5 MFs for every, like each input, each output, or each fuzzy side. There are only 3 over here. So you need to add 2 more. So just go to edit, add MFs, select 2, and there you go. Okay. Now another practical tip. You see this name MF1, MF2, MF3, MF4? They will be arranged in this fashion when you go to rule writing form, like when you write if then form. So it's better to maintain this order over there. Otherwise, you may find like negative high here and then immediately next there is 0. So it's not convenient to write. So what I do is say MF4, where is MF1? Yeah, this is MF1. MF1 is negative high, right? Okay. And if you remember in last class, we discussed that the extreme ends, they should be trapezoidal always, right? Because you don't need to leave something uncovered. So we'll change it to trapezoidal, right? Our range is say -1 to 1 because your error can be -2. Okay. So I just let us say starts at -1, -1 and -0.8 and -0.6. Okay. And then second thing is MF2, that is negative small. Okay. I'm rushing because we don't have much time. We still need to design a simulation system. So this can be negative. We'll discuss on that later on. This is MF4, where is MF3?
0.
MF3. MF3 is 0. Okay. Now, this is triangle. So I take it from. Now you will observe I have chosen very small area for this 0. Now width of this will determine your steady state error. This thing. It will determine your steady state error. If you keep it very big, you will have large steady state error. So usually whenever you see any design system, they have like very narrow 0 region. So we are going to follow that same pattern. This is negative small. Yeah, this is negative small and signs at -0.6. Negative small can end at 0.
This is negative 5.
Sorry? Oh, no.
Negative small.
Negative small. Can end at 0.
Minus 0.8. Okay, no problem. Minus 0.6. Minus 0.6.
Remember, all I need is overlapping. That is it. That's it. Okay, MF4 is
Positive small.
positive small. It can be triangle, no problem. And this guy is positive high. And it has to be trapezoidal. It is defined positive small. Okay. Okay. Well,
Overlapped and everything.
you can fine tune it. Anyhow, I'm rushing right now. I'm not doing very good job here. Same way for error dot. Right.
If we make it this membership, it will be fine. At least 3 membership.
See. Question is really good. Why should we use 5? You know, if I use only 3, then my task will be much simpler, right? If you use only 3, then your accuracy is going to be much lesser than this, because you tend to cover more region here. You tend to have more logic, more what you call inference compared to 3. See, if you use only 3 membership function, you will have only 9 rules, and you will have much less regions than this thing. That's why you use 5 rules. And I am using this 5 rules because I recommend when you design your project, you use 5 membership function as well. You know, it will give you good results. So I think I don't need to define this all over again. Right? I have something ready already. You can check over there. So we'll just close this thing.
Can we copy one
I'll show you.
configuration
Just
of
hold on.
membership?
Okay. Now, there's very useful thing. Important thing. When you okay, I'll show it in Simulink. Then there is this command. Okay, where it is? Yeah. You see this read FIS. Read FIS. Read FIS. So it will read the fuzzy logic inference which you just designed in fuzzy logic toolbox, and you need to load this thing. You see this here. Now this thing has to be in workspace, otherwise your segmenting model will not run. So one way to do it is like just you simply go over there and open that file, FIS file. You see this? EI fuzzy FIS. So you just double click it and this will be loaded itself in workspace. Other way to do it, you use this command, read this. You can note it down if you want. It's really simple. There's nothing. So yeah, we'll check in fuzzy. So I will import it from file because I designed it earlier and I saved it in my file. So I will load it from my file and this is PI fuzzy file. So you can see it. Everything is designed here. So you have error, same way you define. Then you have error dot, and then you have output, same way. Each 5 membership function for all of them. Now, this are these are
If error is
if then
25
formats, yeah.
road.
Okay, so we did the diagonal. So we can verify one of them. Like first one, what is that? Negative. I use big or high. They are same. So when error is negative high, you can see this first rule highlighted in blue. See, error is negative big or high, and error dot is negative high. Then output is
Negative 5. Huh.
Positive high.
this may be the other file, I think. Anyhow.
Negative big, negative big is negative.
No.
Well, negative big 0, negative big bad.
Or maybe I have defined error in different way. Maybe reference and actual. Maybe I might have done something reverse, like actual minus reference. Anyhow, so your rules are going to be like this. So according to our system, it should be positive big. So like positive big, change it. Okay? So that way you need to add all of these rules here. Right? So for example, if you need to add something, you say when your error is 0, error dot is 0, your output is 0. So just add it. That is it. So that way you will add all of that entries. See, so if you use 3 membership function, then you will have 9 rules. If you have 5, then you will have 25 rules.
The last rule you said positive high and the error dot is positive high, then the control action is positive high.
Yeah, that's what I said. When I designed it, I might have used like error is equal to actual minus reference or something else.
Can we set if it's negative high, the error, whatever the error dot, positive high? Is it correct as a
Yeah, it depends. It's your logic.
No, I mean the systems, the control systems. I mean the BID, the controller. It depends on the error and the dot. But if
See.
one of them is high,
See, usually if your error is negative high, you want to change your control action
Yes.
by big amount. But then it depends. If you consider error dot, like rate of change, then and say error is negative and rate of change is positive, then you can apply small amount of positive.
Okay.
If it is like very high, then you can apply the higher amount. So it depends. It's just a fine accuracy, nothing else. So yeah, once you have designed this, enter fuzzy rows and everything, this is important. You export it to file and you just save it, give whatever name you want, and that is it. That is the name you will use in this read face command to whatever name you will give, you will use it here to load your FIS file in workspace. Now once you have done that, then it's a simple matter of Simulink model. So this thing is the transfer function. This transfer function, simple transfer function. There is nothing magical or nothing at all. This is a simple transfer function. You can access it from here. Yeah. There it is. Yeah. This is this transfer function. You just need to add this coefficients. That's it.
How do
That
you
part
find
is
the
done.
value of k? The transfer function given the value of k, t, and
That's a motor design problem. So everything was given over there. Don't worry. So at the end of a day, you will have a simplified transfer function. So you have those values entered here. Now you have output of the system. You have reference over here. You have error. You have error dot. Input to fuzzy logic controller and see. So say I named that thing while exporting to file. I named that thing pi fuzzy. So that same name I will use here. You need to make sure this should be here. See, let me clear it up. So my model will not. So there is nothing in workspace now. So even though my simulation is okay, it will not run. It will give me an error. See? So
say that
before running your Simulink model, you need to load this here. So you can do it like this. Just click on that. No. Or you can use this command and push that. Okay. So once you have done that, now you can see these 3 gains here. Right? So let me set it to 1.